This is G485 homework booklet, question 17. You are asked to outline the main principles of the use of magnetic resonance to obtain diagnostic information about internal organs. So you want the key physics behind the principle of what magnetic resonance is, but you also need to explain how that reveals information about different body tissues within the body and where they are. The mark scheme allocates a total of 8 possible marks to this question 17a. There are 5 essential marks which I have marked by the bullet points. A further 3 marks can be achieved in a variety of ways with any of the numbers I have shown, like this, as +1 or +2. So I'll run you through the answer. First of all, a key principle on which magnetic resonance is founded is that some nuclei behave as small magnets. You could alternatively say they have a net spin, or they can line up in a magnetic field. You could also mention protons here in the context of hydrogen nuclei. Nevertheless, this idea of protons or the word nuclei is important. Secondly, in the process of magnetic resonance imaging, a strong magnetic field is applied. An extra piece of detail worth a mark is that when this magnetic field is applied, the magnetic axis of the nuclei, which is slightly different from the exact orientation of the magnetic field, this axis precesses around the direction of that external field, and it does so at a frequency that we call the Larmor frequency. You can, in your head, have a picture of a spinning top and how that spins, but also rotates or precesses around an axis. The third essential point is that during the process of MRI, radio frequency pulses are applied. Now, what effect does this have? Well, these radio frequency pulses produce resonance if the frequency of the pulse matches the Larmor frequency. Alternatively, you could gain a mark for saying that this radio frequency pulse can make nuclei flip their energy states. Following on from this point, you need to say that when the radio frequency pulse is turned off, the nuclei flip back, or you may choose to use the word relax. An extra piece of detail here is that when they do this, when they relax, they themselves emit a radio frequency signal that can be detected and the information processed. The final essential marking point is tied up to the mark for quality of written communication, and that is to state that hydrogen or nuclei within different tissues have different relaxation times. So here we have the technique to reveal the nature of the body tissue from which the pulse was emitted. Obviously, that's key to diagnosis. Finally, there is extra detail and marks available for explaining how you know where that particular body tissue is within the body. And this is achieved by applying a non-uniform or gradient field. So different parts of the body are exposed to a magnetic field of different strengths. This actually influences the Larmor frequency, and therefore the frequency of radio pulse that will cause resonance. And by doing this, we can tie the information from the detected radio pulse, for which the relaxation time reveals the body tissue type, to a position within the body. Finally, describe an advantage and a disadvantage of MRI. A choice of 2 advantages. Very importantly, it is not ionising radiation. So that's a very positive factor in terms of not leading to cell damage and an increased cancer risk, for example. However, it's also valid to say that the technique of MRI allows better soft tissue contrast. Disadvantages of MRI. Any metal objects can experience a heating effect. This can make it inappropriate to use for cardiac pacemakers, and also it may interfere with their operation. And finally, an MRI scan takes a relatively long time to complete. So any one of those 3 points would be valid.